Hi, this is Vlog entry 137. Currently, it is about noon, 12:22 p.m. to be exact, CST, of course. And so busy. For the most part, my body was like, I don't know, I was tired yesterday, so I gave it a little bit of time to lay down. I actually fell asleep for a good like 2 hours at around 4, and I got up at 6, and that I haven't done that in a long time. So I kind of felt like I was in a weird. Would be the. It kind of felt surreal to me because it's been a long time since I've been in that state. Last time I was in that state was actually back in February when I had nothing better to do but to think and sit and mess around with my computer and look for jobs and think about abstractions and other stuff. But yeah, so I'm kind of in the same, going through the same patterns again, which is not a bad. It seems like it's a loop, but it's more of a spiral from my perspective because I have gained significant resources to change my life in substantial ways that again, like I've had these moments where I couldn't see the physical change. I couldn't see it with my own eyes, but I knew it was there. It's just that I happened to have I mean, like you can think about like I was also thinking about like non-locality and all that, and the conservation of non-locality has to be a thing. I think that's why people are having a lot of trouble nowadays when it comes to physics, because of locality, non-locality. For there to be non-local, there's also local mechanics in a different world or a different dimension, whatever you want to call it, and you can imagine as you wish, which is why Einstein had a little bit of trouble understanding, well, spooky action at distance. That's actually the phrase, the direct phrase that he used, and yeah, I mean, it goes into like the what is it, the Einstein-Rosen paradox or something, and yeah, so that's like having to deal with locality and non-locality and realness. Realness being, at least physicists think of realness as like a particular object, and that particular object having those set qualities, innate qualities that are not really acted upon from the physical universe. Of course, there are certain qualities that particle may have that changes over time. Like it can be stationary, but then of course if a force is acted upon it, then it will start moving. It'll have a velocity of some sort. That is not an innate quality, but people talk about spin a lot, and they've I don't know how they actually found an experiment that kind of disproved disproved the realness of the universe, other than yeah, I don't know how they did that. I actually don't know how they would have done that. How would they take the same particle? And maybe they had it going through multiple systems, and because it's kind of funny. Because like if you realness is obviously not a thing for my framework that I use. My framework also kind of explains locality and non-locality to an extent, and the conservation. It's like another conservation law. The conservation of locality is locality and non-locality, meaning that if there's a local thing, then there's also a non-local thing. It's kind of weird to think about, but local and non-local are negations of each other, so it has to happen within my framework, because my framework completely utilizes non-duality and harmonization, or nature's tendency to harmonize, so of course that has to happen. Yeah, so it just has to encapsulate all those things. It's just a ramification of the law of the nature. Yeah, so yeah, I've been thinking a lot as usual, and I guess expounding on real things, like if you think about a particle, an electron has a certain spin. From my perspective, these particles aren't actually, for each dt, they're not actually the same particle. That kind of makes sense. These, if you think about like a computer, right, and you have a person that's moving through. This person has innate qualities, but also it's not really it anymore for each dt. I guess you think of it as like being and becoming and whatnot, and that can also, I mean, of course, physicists are going to have a lot of trouble with that, because they're going to be like, okay, well, like, is there any constant? Like, no, there isn't any constant. There's not. Like, the constants that we use in this reality are obviously going to be variable in other realities. So we only see constants. Actually, I don't. We only see constants because of this world, that it's our brain basically trying to come up with some kind of interpretation. Of course, we can create patterns, which then create a constant, and spin is not one of those constants, unfortunately. So now I wouldn't be able to provide a good explanation other than the fact that you can see it from a computational perspective. Because actually there is a thing in quantum electrodynamics, they call them creation and annihilation operators, and these creation and annihilation operators kind of destroy the particle and then recreate in a different dt dx. I say dt dx because of space-time and whatnot, but I don't know. I'm just talking from a very high level point of view and whatnot. But yeah. So now the thing is that these creation and annihilation operators can actually not just act upon the spaces that we see in space time and whatnot. They also act upon other spaces. These spaces are commonly known as vector spaces, and of course I'm going to be using vector spaces because I use that's the best way to really think of it, is through fields, and these fields have certain qualities, and they work well with vectors, and vectors tend to explain pretty much anything about how we can actually conceive of reality over some kind of metric space. Of course, it has to be over a metric space. Metric spaces are they have Hilbert space is a metric space, Banach space is a metric space, but I don't really feel like having to talk about the mathematical qualities and all that. But they have to be metric spaces because we have to, of course, measure. And yeah, so now aside from all of the philosophical ramifications, I've been looking more into the math of the linear algebra applied to quantum mechanics and whatnot, and I was looking at the operators and why they use operators and the importance of operators from a linear algebra perspective. Of course, we'd be doing that because these operators are all linear. They're linear transformations on a vector space, and these linear transformations, they're nice qualities. Linear transformations have nice qualities, and now, when you take these operators are also, I think all of them are Hermitian operators. Hermitian operators are nothing more than, well, are they all Hermitian operators? I'm not sure. Or they can be seen as Hermitian matrices. Operators can also be mapped to a matrix because you're imposing some kind of information transformation on a particular vector. So these vectors are obviously infinite dimensional. They're not necessarily infinite dimensional because there is a dx, but they're big. They have a lot of dimensions, and there's a dx, there's a de as well. And also these de's probably pertain to the fine structure constant, because I remember hearing about these things. And so the fine structure constant has to do something with the more finer energy deviations, so amongst orbitals and all that. So they're basically DEs in between each n, or each energy pertaining to an orbital. Of course, they map to them because an energy, when you have a lower orbital, that's the least amount of energy, and then when you go to higher ones, they tend to have more energy, which means a higher frequency and all that. So now I can't really, and I think that kind of they tie into harmonic oscillators to some degree, so I have to look into that more, and I haven't looked at harmonic oscillators as much as I'd like to. I'm going to be looking at more complex harmonic oscillator systems, like how you can actually think of. I'd naturally think of it intuitively, but not from a mathematical perspective. And I'm going to look more into like the definitions of these structures and whatnot, and all that. So yeah, so I've been spending my morning today doing all that and thinking about those things and creating an intuitional basis under quantum mechanics and whatnot, and how it ties into observables, which are basically just how we measure things, because of course our brains don't like probabilities, but these probabilities are actually a thing, and they happen to tie into observables. And I'm still kind of confused about like the quantum wave collapse. Like, is that actually, does it actually, I like, how can we have enough how can we have such precise instrumentation to actually say that there's a quantum wave collapse? I don't think that's actually the case, but I could be wrong. But it's the best way to model it for the time being, because again, we want to go into a more classical perspective of this, and that's the best way of how we can explain it from a more, again, quote-unquote Newtonian perspective, because we're always trying to tie waves into particles, because we still believe particles are everything. But I stand firm in my perception of how I see physics in general nowadays, and I think it can all be seen from just waves and information. Um, yeah, and I've talked about the non-term perspective fields and whatnot. I don't feel like expounding more on that until I've gained more clarity in quantum physics. So I've been busy. Um, I still have to look at Ricci curvature tensors. Again, like that's more GR. I like to, like, since we don't really understand how to unify GR and quantum mechanics, I'm refocusing more on quantum mechanics first before I looking at GR stuff, because I have a general understanding what GR is like and why it happens. I haven't looked at accelerating frames and more of the inspiration behind Einstein's perspective of why we should curve space-time and whatnot. And I'd like to look at him, like how he thought of it as from a historical perspective and whatnot. Just I just want to, I don't know, when I think about particular subjects and how these ideas evolve, I like to see them from my story. Of course, you would want to do that because these were the minds that actually created these concepts and whatnot, and I want to be in their boots to see if, like, maybe to see if this is actually a good proposition, and it probably is, because Einstein was a smart guy. He was considered to be a genius, so I mean, I can't. Yeah, so I have orange juice here. I've been drinking it. And, oh, of course, you guys have been seeing that in my video, and then my banana. I always have my banana with me. Yeah, so. I'm going to keep looking at this stuff, and I've been looking at, I think there was a Nobel laureate that won the, well, yeah, that he basically was, he found a way to experiment or find empirical data on why on the universe being either it's one of the two or something. It's either it's all real or it could be both. I don't know. Maybe it's an Endor. Maybe it's an Endor. I forgot. With the yeah, there was a Nobel laureate that basically somehow found empirical data on the locality and the realness of the universe that we live in and whatnot. Is the most. I'm vague because I don't remember what he found and whatnot, so I had to read into that before I can really say anything. I just saw something on Reddit one day. It was like a year ago, and they mentioned it, and I just don't remember. So yeah. So yeah. I had to look at Bose-Einstein condensates as well, and others. Just I have a lot. I wrote on my board again because I just have a lot that's going on right now when it comes to the stuff that I'm more interested in as of now, because I don't want to get myself overwhelmed. There are a lot of concepts I'm going through, and I've decided to at least have a time chunk of 6 hours every day, which is 42 hours like full time while I'm unemployed, to kind of work on this stuff. And I'm balancing 6 hours for physics, and then so 3 for computer science and 3 hours for physics. And I kind of want to implement the Pomodoro technique, which I have not been doing. I think the Pomodoro technique is a great way to actually increase your productivity. And yeah, so I'm going to do like a 25-5 or something. Every 25 minutes, I'm going to have a 5-minute break. I've never done it before, surprisingly, but it seems effective if you're trying to accelerate the learning process of things that you're actually somewhat interested in. And there are studies of it, and I just hear it a lot. It's like, I mean, if it's circulating through the internet amongst Reddit, okay, Reddit's not the most reliable resource, but I think if it's talked about a lot, then it's probably pretty effective to some degree. And also just by kind of accounting for like the brain and how long the average brain can focus. The average brain typically can focus about 30 minutes, and then so on one thing. But yes, so I'm flip-flopping at 1 p.m. I'm going to be going to Golang and studying its syntax when it comes to its primitive stuff, like primitive computer science 101 stuff, like how they devise functions and how you define them, and how just like the overall structure of functions and all the ways that you can actually call, basically define a function. Because there are multiple ways. That's how most languages are like nowadays. They have different ways of calling, of defining a function. So yeah, I'm going to be looking at functions, types, loops, and conditionals. Very primitive stuff, but it's a good way to kind of reintroduce yourself to a new language. Also, for me, I've only learned Python and C, so I don't have I don't have a huge umbrella when it comes to understanding the languages, computer science languages, and seeing the patterns as easily as other people who've learned, I don't know, like 5 or 10 languages in computer science. For people who've learned that much, probably can go through functions, types, loops, and conditionals within probably like 30 minutes. They'll just kind of like connect the dots and be like, oh yeah, this ties into this language, and this looks familiar to this language, and say, oh, they're kind of, I was kind of doing that. Like, there are a lot of similar things like Func. I think Func actually has, I think that's like a Rust thing. Maybe it's a Rust thing. Again, I don't know Rust. I've looked at it a little bit, but I don't really know it. And is that a JavaScript thing too? I'm not sure. But yeah, so I wouldn't know where Func comes from. But it's the thing you have to do. But anyways, like the point I'm trying to make is that people who learn multiple languages, obviously you can map this to I don't know, like learning a world language as opposed to a computer science language, and it's kind of the same thing. Especially if you're learning it in one domain, like, okay, if you transition from a romantic language to a more like Russian-esque, I don't know what to call it, is it non-romantic or like Scandinavian language maybe? I don't know if that's really a good way of thinking of it, Scandinavian, I don't know. Or, if you're going from Romance to Germanic and whatnot, then obviously they're so different that you can't really see the patterns as easily, but, but for computer science, it's like, I guess the analogy would be just kind of comparing between different romantic languages, pretty much. I don't think there's really, it's the same thing. Like the primitives, right? They use loops because you have a timer in a computer, and you have to do a certain amount of. You can break loops into functions, and they don't have to be functions, it's just like steps, Of course, you can talk about assembly language and all that, but of course, these are loops. I actually don't even know assembly language, which is, I feel kind of bad that I don't know assembly language. That means I really don't understand computers as much as I'd like to from a more software perspective. Assembly language is actually the closest you can get to the hardware to some degree. Anyways, what I'm trying to say is that, this is a language of a computer that can be broken down to assembly language. If you understand C, then you'll be able to understand these languages more and actually at least have some more appreciation for them and whatnot. And, functions are nothing more than just a way of encapsulating a series of steps that you use a lot, basically. That's basically what a function is, and you name that particular series of steps something. You can call it a subroutine. I think people who use 4chan actually call it routines and subroutines, and I don't understand. Like, routines are probably like main functions, and then subroutines are the actual functions I'm talking about. So it calls in subroutines to do that. So that's probably like the analogous approach from the 4chan perspective. If you guys are older, and my dad likes 4chan, so anyway, so that's basically what functions are, and types are, of course, types are, you can just see from a mathematical perspective. There's really nothing else to think about from that, other than like, it's a contextual thing, I guess, and of course you have to know certain types. Like, if you have a variable and you have it in memory, then you have to know the type for it to be stored in memory, because like there's in32, there's in 64, bigger integers, which require more bits, and it's not just ints. You can floats as well. I forgot how floats are actually stored in memory, and because floats actually contain decimal points, and these floats have to be somehow stored in bit format, I guess. I'm assuming that there's like some kind of separator for the decimal, I guess. The point in between. So yeah, like on the left side you have a series of bits, and on the other side you have another series of bits, and now to that series of bits on the right side, I don't really know of a good way to see it from a binary perspective, and of course I don't really have to see it from a binary perspective because I'm not messing with computer architecture, so I don't. Anyways, that's maybe something I'll look at later out of just curiosity. And of course, loops and conditionals, and loops are interesting as well. And again, it's just like a be another way to say it, loops. Why do we use loops so much? What would be a good reason? I mean, of course, you can think loops from a game perspective because it's under a clock, and of course, you can define that loop to have one function, embed it that way. Say it's like this is the game function or whatever. You can loop and then game function, but then obviously that wouldn't be readable, right? So of course you have to abstract it to the enough towards readable, to where you have like these certain functions that can be segregated to then be called, and then and also functions, at least from what I've learned, functions are not really, you don't want functions to be that big. You want functions to be somewhat, maybe like 10 lines, 10, 12 lines. You don't want them to be too big just for readability. And so what people usually do is that if they get too big, you can either call another function that defines another subroutine to make it smaller, and then you'll understand that, I don't know, like, I don't know, what's a good example? Like if you're, man, I haven't done game programming in a long time, so I can't really give a good example, but, like if you have like Blit or something, or, rendering is a huge thing, and, if you're rendering something, well, you have to call certain GPU functions for you to actually get the vertices and whatnot that could explain a sprite of some sorts, and of course there are other things in the rendering process you have to understand, is like where these things move, and then there's like there could be a function pertaining to a button press or an event, so that button press could be a subroutine for that, and button press goes up by, I don't know, if you're like playing a 2D game or whatever, the up arrow would just insinuate that you're going up the y dimension, or left or right, so negative. And also they for some reason they flip it. I don't know why. At least from the computer program that I've done, they flip the axis, so negative is at the top and then positive is down. I don't know why they do that. I think probably because you start at the top left. I don't know. That means you're going up if you're doing that, so that means the origin is at the top left instead of the bottom left. That's probably now I don't know why they do that though. Other than like from the only thing I can think of is like, I think when you write on a screen, at least the GPU is talking to the screen, the driver for it, when it writes, it goes from left to right and then down, which is maybe why they have that there, and that's how they've just used the axes for it. That's my best explanation. It's top to bottom instead of bottom to top for writing on a screen. I don't know. Again, I don't know why they did that. It's just convention at this point, and whatever. I'm tired. I said I'm tired. I'm still thinking. So yeah, I have quite a bit to do. So conditionals, and again, I'm looking at the primitives for Golang first, and then I'll start looking at modules, then linking modules to make bigger projects and whatnot. And then after I do modules, understanding how to build modules, linking modules over the Go commands, probably use some kind of Go command to build modules, or say it's a module of some sorts. And I don't know if you can put this in the, I guess you'd have to put in the executable path, of course, to link these modules and whatnot. But the executable path could be pointing at the project folder, I guess, or some shit like that. I don't know. And I guess again, you can think of like different environments and whatnot, and these environments are basically, in Python you can create environments, and these environments contain all the stuff that you need, and you sometimes you can copy from the standard library and just put it all in one folder, and then you can have a path pointing to that for the executables, because it's all binary, I believe, once you build it. So, and then it will just, I don't know all the details. I can't really explain it well. It's been a long time. I guess it would be considered shared objects. are the ones that are actually contained in the like the general library of a particular language, which is typically in like user/bin or something, usr/bin, or something like that. And well, /bin is usually the place they have it. Yeah, and they're called shared objects because once you compile it, it's an object because it's all just zeros and ones. I don't know why they call them objects, but it's a general way of. I don't know all the reasons why they have these names and whatnot. Anyways, yeah, so that's just random computer stuff that I'm looking into, and I don't want to think too much because, again, it's just I need to pace myself, and yeah, just a lot to do. Like to keep myself busy. Yeah, so I was also tomorrow. I'm going to be looking at the. I forgot to mention that I also had to look at the HTTPS module. They have a nice. That's actually a part of their standard libraries, HTTPS. And so, I'm sure if anybody has any kind of web programming, when you're programming the like a server or whatever, it usually fetches things like certain HTMLs, and then it takes it and I guess it takes those scripts and it can contain a lot of things. HTML is hypertext markup language, and you can embed JavaScript in it, and it can do certain functions, and then it can call functions and then operate on variables and then displaying it on the screen. But HTML is good, I guess, for web documents. I don't know why. It's just a standard that they've used to. What's a good way to say this? It's a standard that they use to kind of write documentation, I guess, or for not really graphics, but not really graphics, but it's just a good way to encode information, map it into certain parts of your screen and whatnot. And again, I've never actually used HTML. My brother has and whatnot, but I never had a good reason. Now I have to learn all this, so I'm just like, oh goodness gracious. What are they called? HTTP requests? I think those are, that's what they call it. And that's like a request to, I don't know, like an IP or something, and the IP contains. Oh man, my knowledge of this stuff is like beyond me because I've never done this, but I'm assuming that the HTTP requests are this hypertext transfer protocol. So it's hypertext meaning that it's live to some degree. I don't know, like HTML hypertext markup language. It's live because you can embed JavaScript to make it seem live. I don't know. Maybe that's a good way to say it, but I don't know what the hyper means. It's just how. Anyways, yeah. So, and then you have, when you have S at the end, that's secure. It's probably some kind of encryption language or encryption that they have. Yeah. So, what was I saying? Yeah, I was just trying to think of it like from a very rudimentary perspective, like how this works. I mean, everything is in the web is kind of built from HTTPS and HTTP. Most web domains, I guess, would be the good way to say. Most domains support HTTP, usually, and that's why they use HTTP as hypertext transfer protocol, and that's why we use a browser, because our browser sends requests to these servers, and they hold all this. These servers usually are there some maybe you can segregate between different servers. I don't know how they do it. You could have like JavaScript servers, I guess, or maybe servers talking to each other to then, codify it and then send it to the computer with the right information. But I don't really know how these servers work exactly. I just know that you have databases and they have the servers, and these databases contain information. These servers fetch from the database. They may modify the database to some degree, not modify, but take that information, modify it itself, and then to, I don't know, like, you can think of like functions and whatnot to then blit it onto a computer. And of course you need an IP because you need to know which server you're accessing and whatnot. So the IP I guess you can think of it as a way of directing to a server. And then this IP is almost like an operating system. It's typically Linux. I mean, they have like headless Ubuntu, I think is headless Ubuntu is actually a pretty common operating system that they use in servers. And so these IPs are basically hosts. I'm a host, and like I have an IP to my machine, pretty much. Well, I don't think that's a good way of seeing it. I have a local IP. I have a local IP within here, but then there's an external IP. You can call it an external IP, which maps to the router that I'm at, I guess. I guess router would be the external IP. And then that external IP talks to my internal IP, which talks to multiple different IPs. But you could segregate between internal, external IP, or local and external IPs. Local. Yeah. So I'm not a hacker. I don't hack. I'm a good person, usually. Yeah, so that's basically how it works. I mean, that's how you can map the web and whatnot, and why HTTP requests are needed, I guess. It's just what they call it. That's basically what the browser's doing. It's just sending a bunch of HTTP requests and then taking those HTTP requests and blending on your screen, I guess. This is the best way I can see it, because again, my knowledge of all this stuff, I can't really give all the details. It's kind of spattered. I don't know. There's probably a better way to, obviously there's a better way to explain it with somebody that actually knows what they're doing if they're in like cybersecurity or something, but I don't know. I'm just interested in all this stuff. Too many things at once. Again, which is why I think my body's probably going to crash in the next week or so. Again, another thing is I can't say much because I haven't programmed a website before. I haven't built a website. I haven't really built anything pertaining to any kind of web stuff. I don't know. It just doesn't seem that interesting to me. I mean, it's kind of cool, like knowing that knowing the universality behind the web and whatnot. But I appreciate it. I appreciate the technology, but I wouldn't necessarily say that I am as interested in building websites as other people. And of course, I don't think it's really, back to where it was in its prime, where we didn't have all these frameworks. The expertise of building webs was actually necessary when it was primarily HTML and JavaScript and whatnot. But nowadays, you have boilerplate code, you have all this other stuff to make it super easy. You can just streamline building a website in, within a day. And now they have all these frameworks, which don't talk to me about. I don't know anything about frameworks, web frameworks. And I actually had to look into a web framework that is supposedly used in tandem with Golang called Jin, so I have to look at that as well. And I kind of want to work on my general knowledge of servers and databases and how that stuff works under the hood. So I had to probably do some research on that. Yeah. Lot to do. Yeah, I have a lot to do. I don't know what else to think about. That's basically an update of everything I've been looking at so far. Pretty long update, 30 minutes, but these videos help me out with keep myself on track, because I know and not only keeping myself on track, but actually understanding that I'm making a lot of progress within just a few days. And also I like going back to these videos because I have a lot of questions that I don't write down on my notepad. So it kind of helps out with me kind of tucking those questions into a video as opposed to it looping in my head. So that also helps out with my productivity quite a bit. I mean, notebooks are good and all that, but if I wrote down all of my questions on a notebook, within a couple of days, that notebook would be. I would have to get a new one pretty quickly. Yeah. So that's why I talk about this, and I'm hoping that I think yeah. Anyways, whatever. I'm gonna be quiet. 1 o'clock. I have to start this stuff. Okay. You guys have a good day. Bye.